Okay, in this example, we're supposed to write the equation for a fourth degree polynomial with a root of the square root of 5 and a root of 3, and specifically the root of 3 has a multiplicity of 2. So, first of all, we need to figure out all the roots for our fourth degree polynomial. It being a fourth degree means that we'll have 4 roots, counting multiplicity, and counting complex roots. So right now I know that I have the root 3 that occurs twice. So I'm just going to make a note. Times 2, multiplicity of 2. I also know I have a root of the square root of 5. Well, according to the conjugate root theorem, if I have a root of the square root of 5 or an I, then I also have to have its opposite counterpart or its conjugate counterpart. So if I have a root of positive radical 5, I must also have a root of negative radical 5. Okay, and that's by the conjugate root theorem. Now that I have that, we can go ahead and start writing, because this gives us our total of 4 roots, the 2 from the multiplicity of 2 and then these 2 here. Well, starting with that, going next to the actual factors so that we can write the equation. If I have a root of 3, then its corresponding factor is x minus 3. And because it has a multiplicity of 2, I know that this is squared. If I have a root of radical 5, then I know that I have a factor of x minus radical 5. And if I know I have a root of negative radical 5, then I have a factor of x plus radical 5. Now, it doesn't specifically tell us what form to write this equation in, so I could technically just throw a y equals on front of it, but typically, when you're asked to write the equation for a polynomial, it usually helps to be in standard form. So we're going to go ahead and distribute stuff out. So, going through, we're going to distribute these. So x times x squared. X times radical 5 is x radical 5. Negative radical 5 times x is negative x radical 5. And negative radical 5 times positive radical 5 is negative radical 5 squared, or in other words, 5. There's a number of ways I can go about doing this. In fact, I can also remember that these two are conjugates, which means the middle 2 terms will cancel out, leaving me with x squared minus 5. So we've now distributed that part out. Let's go ahead and take care of the other factors. You can do this in two ways. One of them is by writing out the x minus 3 twice and distributing that out. Or you can remember or try to apply one of the patterns. This is a perfect square pattern, so it ends up coming out to be x squared minus 6x plus 9. And lastly, we just have to distribute the remainder out. So x squared times x squared is x to the 4th. X squared times negative 5 is negative 5x squared. Negative 6x times x squared is negative 6x to the 3rd. Negative 6x times negative 5 is positive 30x. 9 times x squared is 9x squared. And 9 times negative 5 is negative 45. If I combine like terms and write in standard form here, we have the x to the 4th as the highest power. We have, it looks like 1x to the 3rd. Yep, just double checking, I didn't make any mistakes. So negative 6x to the 3rd. We have negative 5x squared and 9x squared, which makes positive 4x squared. We got just 130x. And we got our last negative 45. And there we go. Okay, in this example, we're going to write the equation for a quadratic function with rational coefficients in standard form so that the 2 plus 5i is a root. Now, since it's a quadratic formula, that means there are 2 roots. because of the fundamental theorem of algebra. Now that we know that, and we already know one of the roots is 2 plus 5i, and because of the conjugate theorem, if 2 plus 5i is a root, then 2 minus 5i is also a root, which means I have all the roots for this quadratic function, and we can begin writing the equation. Now the roots and the factors are opposite signs, so a way of denoting that in algebra is just putting x minus the root, which is 2 plus 5i, and x minus the root, which is 2 minus 5i. Oftentimes you'll see in the formulas x minus r for the root. Now that we have this set up, we're going to have to do some simplifying and then some distributing. So distribute our negative through. So our first factor is x minus 2 minus 5i. And then we'll distribute the negative through on this one as well. So we'll have x minus 2 plus 5i. Now with these two roots, since the roots are conjugates, they should in some way have middle terms canceling out. But it's not something you actually see very often, so we're going to go ahead and distribute things the long way here. X times x, we have x squared, and went too far. X times my negative 2 is negative 2x. X times 5i is 5xi. Then go through with negative 2, negative 2x, positive 4, and negative 10i. And then we'll change colors for the last one. Negative 5i times x is negative 5xi. Negative 5i times 2 is positive 10i. And then negative 5i times positive 5i is negative 25i squared. Let's see. Some stuff should cancel out because, again, things are conjugate. Conjugates involving means that we're going to have some stuff cancel out. So the 5xi's will cancel, and so will be my negative 10i's. Anything else cancels? I don't see anything. Yeah, okay, so we're good with that. We also have to remember I squared means something. I squared is negative 1. So this last term is really negative 25 times negative 1, which is positive 25. If I bring everything else down, now I'll finish combining like terms here. Okay, we got our last term. Okay, combining like terms, we got the negative 2x minus 2x gives me x squared minus 4x. And then 4 plus 25 is 29. And there we go. As far as writing an equation, we just have to start sec y equals or f of x equals in front.